All right, so here are the notes for rational functions holes. So a hole in a rational function occurs at the zero of a canceled factor. So it's referred to as a hole because on the graph, you denote it with an open circle. Happens for the canceled factor because that when you cancel something out, you're removing a value from the equation. So when I cancel something out, it's going to leave a gap in the graph that no longer has an x value that goes with it because that's the x value that I canceled out. So the algebra behind the steps, factor your numerator and denominator, simplify the expression by canceling any common factors. If no factors cancel, then there won't be any holes. So it only happens if you have something that cancels. The zeros of the canceled factors, so we take what we canceled out and solve, and that'll tell us where on the x-axis our missing value is. And then determine the y value, we plug our missing x value back in, and that gives us the one missing point that our graph does not have. And then our answer is a coordinate written as xy. All right, so for this first one, factor completely. So that would factor as x plus 1, x minus 1. So simplify the expression, nothing cancels. So this graph has no holes. Down here, already factor completely. There's no quadratics. Nothing cancels though, so no holes again. Okay, so for number 3, let's see here. So this will factor as x plus 8, x minus 8. And on bottom, x minus 6. So once again, nothing cancels. No holes. Eventually we'll probably get one. Let's see here. So the top can factor, that's x minus 10, x plus 10. On bottom, we can take the 2 out first, which gives us this. And then the bottom still has to factor again because it's still got a quadratic in it. So 2x, let's see here, multiplies, it's going to be positive 10 and negative 5. So in this case, our x plus 10s cancel. So we take the thing that we canceled out, set it equal to 0, and solve. So after we cancel, our expression is x minus 10 over 2 parentheses x minus 5. So that finds when we solve what we canceled out, that gives us our x value. To find the y value, we plug that into the reduced version. So negative 10 minus 10 over 2 times negative 10 minus 5. So that's going to be negative 20 on top. That's negative 15 times 2, negative 30. So the y value will be 2/3. So our answer is negative 10, comma, 2/3. You want to write your answer as an ordered pair. All right, so on top, we can pull the 2 out, which gives me x plus 4. On bottom, can't pull the 3 out because those aren't divisible by 3, so it's just going to have to factor right away. The two numbers, I'm going to guess it's going to be 4 and 4. But let's check. That's 3x squared, 12x plus 4x gives me my 16x. 4 times 4 is 16. So those cancel. So our simplified version is 2 over 3x plus 4. So to find our x value, we set the thing we cancel equal to 0. So that would be negative 4. To find the y value, we plug that back in. So 2 over 3 times negative 4 plus 4. That's negative 12 plus 4, so that's 8, negative 8. So that's negative 1/4. So negative 4, comma, negative 1/4. Okay, and our last one, up on top, we can take a 3 and an x out. So 3x comes out, leaves me x minus 8. On bottom, 5 can come out, leaves me x minus 8. So those cancel. So our simplified form is 3x over 5. To find the x value, the thing we canceled equal to 0. To find the y value, we plug that into our simplified version. So that's going to be 24 over 5, which does not reduce. So 8, comma, 24 over 5. And that brings us to the end of the section.